Now we're going to talk about completing the square. We're going to take a quadratic function in this form. Remember, quadratic is a degree 2 function, and we write it into this form. Okay. This form is maybe more useful to us for graphing, finding a vertex, max, min, things like that. Okay. We could certainly take this form and change it back to this one by foiling it out. Let me just show you that. So if you have it in this form and you want to send it back to this form over here, we just have to FOIL out the parentheses. So that's x squared plus 6x plus 9. Distribute the 2. And then collect our like terms. And we can see we're back to this form. Okay. Completing the square will take us the other direction. It will take us this form into this one. Okay. First step, and you can kind of see what our goal is over here, we do need to factor out that 2. Keep in mind, completing the square means you're going to fix the constant term. So the first step of factoring out the 2 only needs to be done to the first 2 terms. So it'll be x squared plus 6x. And we're going to complete the square, so we're not worried about the 12. We're pretty much sure that that's going to be wrong anyway. Okay. And here's the part where we complete the square. We put a number here that will make this a perfect square trinomial. Okay. One way to do that is to take the middle coefficient, the coefficient of x, which is 6 in this case, cut it in half, which takes you to 3, and then square it. Okay, so again, first you divide by 2, and then you square. That number, positive 9, will complete the square. Okay. And again, the idea is that this is now a perfect square trinomial, and we can see in the next step that we'll have it as x plus 3 quantity squared. Okay. Now we just changed the problem. We can't just write a plus 9 and change the function. So we have to do something to balance that off. Now we have to be a little bit careful, because we wrote plus 9. Since it's in a parentheses being multiplied by 2, we really added 18 to the function. The only way to offset that is to also subtract 18. Okay. But now we have all our pieces in place, and our function becomes 2. Here is our perfect square trinomial. That's x plus 3 squared. And then collect our constant terms at a minus 6. Okay. And then we have it in what we call completing square form. Okay. So again, first factor out the 2, then complete the square using half the middle term squared. I'll take a look at one more. So we are yet again, we start with the quadratic function or expression. We want to complete the square. So the first thing we do again is factor out that leading coefficient. So I'll take out the 3. From only the first 2 terms, remember, we need to fix the constant. So the original constant, which sort of just put off to the side there a little bit. Okay. Now the challenge is to put the number here that will complete the square. So again, we take our middle coefficient, which is negative 5, cut it in half. I'm going to stick with fractions, so negative 5 halves, and then square it, and that's 25 fourths. That's the number that will complete the square. That's the number that will make this a perfect square trinomial. Now we did just, again, change the problem. We can't change the function from its original value, so again, we wrote 25 fourths, sitting in a parentheses being multiplied by 3, so we really added 75 fourths to this function, which means we need to subtract 75 fourths so that the actual value is not changed. Okay. And now we should be in pretty good shape. This is a perfect square trinomial. That's maybe not as obvious as the one before, but certainly x squared should become the x for the leading term. And then 25 fourths, the square root would be 5 halves. Our middle term is negative, so we know we need a minus there. Okay. I would encourage you to FOIL that out, make sure you get back to the original. But usually you can get your x squared becomes the x, the 25 fourths becomes the 5 halves. And then just double check your inner and outer terms, add to negative 5x. And then again, we have to collect our constants. So let me make a common denominator here first. And then we rewrite one more time. So we have 3 x minus 5 halves squared minus 35 fourths.